This question is asking, given a timer structured as in figure 4.1 C and a clock frequency 10 megahertz, A part is asking determine its range and resolution, and the B part is asking calculate the terminal count value needed to measure 3 millisecond intervals, and the C part is asking if a prescaler is added, what is the minimum division needed to measure an interval of 100 millisecond, and division should be in power of 2, and they determine this design's range and resolution. And D part is asking if instead of prescaler a second 16-bit up counter is cascaded as in figure 4.1b, what is the range and resolution for this design? Okay, so we have A, B, C, D part here, and the diagram for the question is this one. We have 4.1c, that is this one, 4.1d, that is this one. Okay, now let's look at the A part of this question. The A part, they're asking determine its range and resolution. And resolution is easier to find because it's just the period. So we can say resolution, which is equal to the period. Okay, the period is nothing but 1 over frequency. In this case, if you look at the frequency that's provided to us, which is 10 megahertz, I put 1 over 10 mega. Mega is 10 to the power of 6, and this one with this 10 makes it 10 to the power of 7, and it's going to be 10 to the power of minus 7 minute on top, and this is going to be on second because hertz is 1 over second, so it's going to be second. The unit is going to be second, and that's our resolution. And then they are also asking us the range in this question, range and the resolution. Now, in order to calculate the range, you need the resolutions. That's why we have to do the resolution first. Now, the range is nothing but we have to look at how many bit counter. This is a 16-bit counter we are using. So that many power, so 2 power 16, and then multiply that one with the resolution, which is 10 to the power minus 7. Okay, and 2 power 16 is 65,536, and you multiply that one with 10 to the power of minus 7, and we will end up getting 0.00655536 second, and this is our range. And this should be going from 0 to this. So when we give the range, it should be starting from 0. So this is going to be 0 to this range. This one also we can express this one as 6.5536 millisecond as well. Okay, that's the range and resolution for the A part of this question. Now let's look at the B part. In the B part, the question is asking calculate the terminal count value needed to measure 3 millisecond intervals. We want to find out the terminal count value. Terminal count value. Terminal count value is nothing but the desired time interval divided by clock period. In the question, they have mentioned that we need to measure it for 3 millisecond intervals, and the period is also known, that is 10 to the power minus 7 second. So we have both of the values. 3 times 10 to the power minus 3, that's 3 millisecond, and then that one divided by the period, which is 10 to the power minus 7, and if the 10 to the power minus 7 go to the top, that's going to plus 7, and this is going to be plus 4 because 7 minus 3 4. So we are going to get 3 times 10 to the power 4, and that can be expressed as 30,000. Okay, And that's the B part. And let's look at the C part of this question. The C part of the question is asking, if a prescaler is added, what is the minimum division needed to measure an interval of 100 millisecond? And division should be in power of 2. Okay, and also determine the design's range and resolution as well. So here, this is a 16-bit counter. So if you're adding a prescaler, that should be 16. That should be dividing by 16 as well. So, so we can say the prescaler should be set to output a frequency that is 1 over 16, but they are asking us to give it in 2 power, so 2 power 4, 1 over 2 over 4 of the original frequency. Original frequency, which is 10 megahertz. That's the one provided in the previous part of the question right here. Okay, and that is the C part. And also in the C part, they're asking us to find out the resolution and the range. Now for this one, the resolution calculation will be a little bit different. So when we calculate the resolution here, the resolution is going to be 16 times the original resolution. The original resolution is the one we calculated in the A part of the question, which is 10 to the power of minus 7. So you have to multiply that one with 16. 16 times 10 to the power of minus 7. Okay. Or we can also express as 1.6 times 10 to the power of minus 6 as well. And that's the resolution. And that is second. Okay. And then the next one is range. Range is also similar. 16 times the original range. And 16 times the original range is we calculated in the A part of this question, which is 6.5536 millisecond times 6.5536 millisecond. And if you multiply this, you're going to end up getting 104.8576 millisecond. So we can say the range is 0 to 104.8576 millisecond. Okay, you have to just look at for the prescaler what we are dividing with, and that's the one we have to multiply to get the resolution and range. We have to multiply 16 by the original resolution and 16 by original range in order to get the resolution and range for the after the prescaler is added. Okay, now let's look at the D part of this question. The D part of this question is asking, if instead prescaler a second 16-bit counter is cascaded as in figure 4.1D, what is the range of the resolution of this design? So here, as you can see in the figure 4.1D, we have 16-bit counter and we are cascading another 16-bit counter. Now initially for this, all these calculations we did based on is just 16-bit counter. Now if you are cascading another 16-bit counter, now this is going to be 32-bit counter. So for this one, the resolution, it doesn't affect the resolution. The resolution remains the same. So we can say resolution is still 10 to the power minus 7 because it does not change if you cascade another counter like this. But the range is going to change. Initially, if you look at this one, what we do is we take the power of whatever the counter we have and multiply that one with the resolution. So here we use 16 because it is a 16-bit counter. Now it's cascaded with another 16 bit, so that's going to make it 32. So now we are going to have the range to be 2 power 32 times the resolution, and that is gonna make it to the resolution is nothing but 10 to the power minus 7. So 2 power 32 times 10 to the power minus 7, you will get 429.4967296 seconds. So the range is going to be 0 to 429.4967296 seconds. Okay, that's our range. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.